So today we are going to discuss about quadratic equations. What are quadratic equations? These are equations of the second degree, which means that they contain at least one term that is squared. The standard form for this equation is ax squared plus bx plus c equals 0, where a, b, and c represent your numerical coefficients, while x is your unknown variable. There are three ways to solve for quadratic equations: by factoring, completing the square, and by using the quadratic formula. Let's discuss them one by one, starting off with factoring. Here we have two examples, and notice that the second example is not equated to 0, but we'll get onto that in a while. So let's start off with the first example. X squared plus 5x plus 6 equals 0. So we have to look for the factors of the equation. So to get x squared would obviously be x and x. And since the only operation involved in the equation is addition, let's just copy both of the plus signs. So plus and plus. To get the values needed inside your parentheses, you have to look for factors of 6 that will give you 5 when added together. So what are the factors of 6 that would give you 5 when added together? 3 times 2 equals 6. Therefore, 3 and 2 are the numbers you need inside the parentheses. So 3 and 2 equals 0. To get the value of your x's, you have to equate both of them to 0. So x plus 3 equals 0 would give you x equals negative 3, while x plus 2 equals 0 would give you x equals negative 2. These are the numbers your solution set will contain. So now your solution set would be negative 2 and negative 3 enclosed inside a bracket. For the second example, as I said earlier, notice that it is not equated to 0. So what you need to do here is transpose 12 to the other side for it to be part of the equation. So 2x squared plus 5x, transpose 12 to the other side, it would become negative 12. And that is when we will equate it to 0. So now you have to look for the factors of 2x squared plus 5x minus 12. So the factors of 2x squared is 2x and x. So now this is a case of trial and error wherein you have to look for the factors which will give you the values you need inside the parentheses. So 2x minus and x plus. What are the factors of 12? So that would be 4 times 3 or 6 times 2. But in this case, let's use the first one. So 2x minus 3 and x plus 4 equals 0. Again, equate each to 0. So x would now become x is equal to positive 3 halves, and the other one would be x equals negative 4. Again, now we have the values to your solution set. 3 halves and negative 4. So now we move on to completing the square, and the first thing you want to do is to look at the x terms, and ideally you would want the coefficient of your x squared to be equal to 1, which it does in this case, but if not, then you would need to factor it out. Next, you enclose the first two terms of the equation in a parenthesis and make sure to leave a space after the second term before closing the parenthesis. So x squared minus 8x, leave a space, and then you close the parenthesis, copy plus 5, and again, leave a space before equating it to 0. For you to find the numbers you need to fill up the spaces, you need to look at the number or the numerical coefficient of your x. You get 1/2 of that and then you square it. So 1/2 of negative 8 will give you negative 4. And then you need to square it. Negative 4 squared will give you positive 16. copy positive 16 inside the parenthesis, and to cancel it out, we're going to have to subtract it on the outside. So negative 16. Notice that the one inside the parenthesis can actually be factored out, and that would give you x minus 4 and x minus 4. Positive 5 minus 16 would give you negative 11 equals 0. X minus 4 and x minus 4 is basically x minus 4 squared. Transpose negative 11 to the other side, it will become positive 11. And now, since you have a square here, you have to get the square root of both sides. Square root. Now, it will just be cancelled out and you will be left with x minus 4 equals positive negative square root of 11. The solution set will now contain x minus 4, that would give you 4, positive negative 11. The last method in solving for quadratic equations is by using the quadratic formula. So it is x equals negative b positive negative square root of b squared minus 4ac all over 2a. So for our example, we will be using the quadratic formula. So the first term is considered your a, the second term is your b, and c is obviously the third term. These represent the numerical coefficients in the equation. So for a, that would be 1. For b, it's also 1. And c is negative 4. So we just plug in these values in the equation. That would give us x equals negative b, so negative 1, plus minus the square root of b squared, so again 1 squared, minus 4 times a and c, negative 4, all over 2a, which is also 1. So now that we have this, we can simplify it into negative 1 plus minus 1 squared is 1. Negative 4 times 1 is negative 4. Negative 4 times negative 4 will give us positive 16 all over 2 times 1 is 2. This will give us negative 1 positive negative square root of 17 over 2. And this will be our x. Now let's talk about nature of roots. The discriminant is described as b squared minus 4ac. This is the expression under the square root in the quadratic formula. The discriminant determines the nature of the quadratic equation, and the nature refers to the types of numbers the roots can be, namely imaginary when less than 0, real and distinct when greater than 0, and real and repeated when equal to 0. First, we need to solve for the discriminant in order to identify the nature of the root. So, b squared minus 4ac is our discriminant. So, a, b, c, and these are basically the numerical coefficients in our equation. So, for a, it's the first term, so that would be 3. B would be the second, so it would be 2. And c is the third, which is 1. Plug in these values in the formula, and you would get b squared is 4 minus 4 times a, which is 3, times c, which is 1. You would get 4 minus negative 4 times 3, is negative 12 times 1 would still give you negative 12. 4 minus 12 is negative 8, which is less than 0. And again, when the answer is less than 0, automatically the nature of the root is imaginary. So let's have another example, and again we're looking for the values of a, b, and c, which are the numerical coefficients in the equation. So for a, it's 1, for b it would be negative 5, and for c it's positive 2. Plug in these numbers for the formula for the discriminant. So b squared is negative 5 squared minus 4 times a, which is 1, times c, which is 2. Negative 5 squared is positive 25. Negative 4 times 1 is negative 4, times 2 is negative 8. 25 minus 8 would give you 17, which is greater than 0. Therefore, the nature of the root is real and distinct.